Hey there, science fans. Today we're diving into the world of modern processors. You can think of a processor as the brain of your computer, phone, or tablet. It's a tiny chip that does all the thinking and calculating. Without processors, our devices wouldn't be able to do much at all. They're responsible for everything from running apps to browsing the internet. In this essay, we're going to explore how these amazing chips work and what makes them so powerful. Get ready for a wild ride through the world of technology. One of the biggest factors in processor performance is something called a transistor. Transistors are like tiny switches that control the flow of electricity. The more transistors a processor has, the more calculations it can do at once. Early processors had only a few thousand transistors. Today's processors can have billions, even trillions. This incredible increase in transistor density is one of the main reasons our devices are so much faster than they used to be. Another factor is clock speed, which is like the processor's heartbeat. A faster clock speed means the processor can cycle through instructions more quickly. Imagine you're working on a puzzle and you keep the pieces you need most often close at hand. That's kind of what a cache does for a processor. It's a small, super fast memory that stores frequently used data and instructions. When the processor needs to access information, it first checks the cache. If the information is there, it can be retrieved much faster than if it had to be fetched from the main memory. Modern processors use multiple levels of cache, with each level getting progressively larger and slower. Think about a team of workers. If everyone works together, they can get a lot more done than if they were working alone. That's the idea behind multi-core processors. Instead of having one really powerful core, these processors have multiple cores that can work together on different tasks. This allows for parallel processing, which means the processor can handle multiple tasks simultaneously. Multi-core processors are now the standard in most devices, from smartphones to laptops to servers. Section 5: Specialized brains, GPUs, NPUs, and other processing units. Just like our brains have different areas for different tasks, modern processors often include specialized processing units. One example is the GPU, or Graphics Processing Unit. GPUs are designed specifically for handling graphics and video processing. Another example is the NPU, or Neural Processing Unit, which is designed for machine learning tasks. These specialized processors help to improve the performance and efficiency of our devices by offloading specific tasks from the main processor. Section 6: Smaller is better. The incredible shrinking transistor. Remember how we talked about transistors getting smaller? Well, it's not just about cramming more transistors onto a chip. Smaller transistors also use less power and can switch faster. To create these incredibly small transistors, manufacturers use advanced techniques like EUV lithography. This technology uses extreme ultraviolet light to etch patterns onto silicon wafers with incredible precision. It's like using a superfine tip pen to draw the tiniest circuits imaginable. Section 7: Stacking the deck. Advanced packaging for powerful chips. Imagine stacking multiple layers of a cake on top of each other. That's kind of what's happening with advanced packaging techniques like 2.5D and 3D chip stacking. These techniques allow manufacturers to connect multiple chips together, creating a single package that's more powerful and efficient. It's like building a superchip by combining the strengths of multiple individual chips. Section 8: Sipping power, not guzzling it. Designing efficient processors. As processors become more powerful, it's important to make sure they don't use too much power. That's why engineers are constantly developing new techniques to improve processor efficiency. One common technique is called DVFS, or dynamic voltage and frequency scaling. This allows the processor to adjust its voltage and clock speed depending on the workload. When the processor is idle, it can lower its voltage and clock speed to save power. Section 9: The future of processors: faster, smaller, and even more powerful. The world of processors is constantly evolving. Researchers are already working on new materials and designs that will push the boundaries of performance and efficiency even further. Some of these advancements include new transistor technologies like FinFET and GAA transistors. that offer improved performance and power efficiency. Others involve exploring entirely new computing paradigms, such as quantum computing. The future of processors is bright, and it's exciting to think about what amazing new technologies will be possible thanks to these tiny but powerful chips. Section 10, Glossary of Terms, Cache. A small, fast memory that stores frequently used data and instructions. Clock speed, the rate at which a processor can execute instructions measured in hertz, ease. Core, an independent processing unit within a processor. DVFS, or dynamic voltage and frequency scaling, a technique for adjusting processor voltage and clock speed to save power. IUV lithography, a manufacturing process that uses extreme ultraviolet light to create incredibly small transistors. GPU, or graphics processing unit, a specialized processor designed for handling graphics and video processing. ILP, or instruction-level parallelism, a measure of how many instructions a processor can execute simultaneously. NPU, or neural processing unit, a specialized processor designed for machine learning tasks. Process node, a measure of the size of transistors on a chip, with smaller nodes indicating more advanced manufacturing processes. Transistor, a tiny switch that controls the flow of electricity, forming the basic building block of modern electronics. Section 11, Index, Cache, 310, Clock speed, 210, Core, 410, DVFs, 810, EUV lithography, 610, GPU, 510, ILP, 210, NPU, 510, Process node, 610, Transistor 2, 6, 9, 10,